The late 19th century marked a time of boundless ambition. While astronauts dreamed about the life on Mars, a new breed of explorers turning their gaze inward, diving in dangerous early submersibles, probing the ocean floor toward the mysterious depths of our own planet, a world more alien than the moon, filled with perpetual night. Each discovery challenged beliefs. Instead of a flat plain, they found vast mountain ranges, deep trenches, and strange magnetic stripes. These daring journeys didn't just redraw our maps. They demanded a radical new explanation for how our planet worked. The spirit of exploration that mapped distant stars now unlocked the secret about how dynamic our planet actually was. Our understanding of the planet was forever changed by these epic descents. But what did these deep-sea voyages exactly reveal? They provided the final evidence for plate tectonics, one of the 20th century's most important scientific breakthroughs, unleashing how Earth's outer shell, the lithosphere, is broken into massive tectonic plates that float over the softer inner shell. These plates, continental as well as oceanic, are in constant slow motion, driven by heat from the planet's core. The real stark is revealed at the plate intersections. They pull apart open at divergent boundaries, collide at convergent boundaries, and dramatically slide past each other at transformed faults. At some places, like the Mid-Atlantic Ridge, new crust forms as plates separate. At the San Andreas Fault, plates grind past each other, building up stress. When oceanic and continental plates collide, denser oceanic plate plunges beneath the continent, creating deep ocean trenches and fueling powerful geological events. When two continents collide, they crumple and thrust upward, forming colossal mountain ranges like the Himalayas. These boundaries are the engines of Earth's renewal and destruction, shifting from about 2 to 15 centimeters per year. The continuous movement of these plates explains earthquakes, volcanoes, and the ever-changing face of our planet. Plate tectonics is the key to understanding Earth's restless nature. The grinding movement of tectonic plates is the ultimate source of our planet's most awe-inspiring disasters. On average, there are about 16 major earthquakes per year, including 15 quakes of magnitude 7 and 1 quake of magnitude 8 or higher. Stress builds up along plate boundaries for centuries, then releases in a sudden burst. An earthquake. Seismic waves radiate from the epicenter, shaking the land and toppling buildings. The most powerful quakes occur at subduction zones, where one plate plunges beneath another. Underwater earthquakes can displace the seafloor, triggering tsunamis that race across oceans and devastate coastlines. The same forces that cause earthquakes also fuel volcanoes, especially along the Pacific's Ring of Fire. Plate tectonics is a cycle of destruction and creation, shaping the world in moments of sudden fury. Few events happen to unveil the Earth's power in the form of major earthquakes. The 2011 Tohoku earthquake off Japan was a brutal lesson. A locked subduction zone suddenly ruptured, unleashing a magnitude 9.0 quake and a monstrous tsunami. Waves over 40 meters high swept inland, obliterating towns and claiming thousands of lives. The disaster showed how earthquakes and tsunamis are linked, one triggering the other in a chain of devastation. In 2004, a similar rupture off Sumatra unleashed the deadliest tsunami in recorded history, killing over 230,000 people across 14 countries. These events proved that tectonic hazards can have global consequences, with waves traveling thousands of kilometers from their source. The 2004 tragedy was a wake-up call, highlighting the need for international cooperation in monitoring and warning systems. Earthquakes and tsunamis are not isolated events. They are part of a global system of shifting plates. Understanding these connections is vital for saving lives. The planet's power is immense, but knowledge can help us prepare. Volcanoes are Earth's most prominent expressions of the inner heat, erupting where tectonic plates collide or pull apart. The Ring of Fire traces the boundaries of the Pacific Plate, where subduction zones fuel chains of volcanoes. Mount St. Helens' 1980 eruption was triggered by an earthquake and a massive landslide, unleashing a lateral blast that flattened forests and blanketed the region in ash. Sometimes the danger is water eruptions can melt glaciers, creating deadly lahars, fast-moving volcanic mudflows. In 1985, Nevado del Ruiz in Colombia erupted, melting its ice cap and sending lahars downriver, burying the town of Armero and killing over 20,000 people. These disasters show that volcanic hazards can travel far beyond the volcano itself. The interplay of tectonic heat and surface water creates threats that can strike without warning. Volcanoes build and destroy, shaping landscapes and lives. The forces beneath our feet are as unpredictable as they are powerful. The map of our world is just a snapshot in a billion-year story. Plate tectonics has endlessly rearranged continents. Once all land was joined as Pangaea, then slowly torn apart. Fossils and rocks reveal this ancient journey, showing how continents drifted and oceans opened. The Wilson cycle describes this rhythm. Oceans are born, widen, then close as continents collide, raising new mountains. The Appalachians are scars from a vanished ocean and a collision that formed Pangaea. Sometimes, rapid plate movement and volcanic eruptions have changed climate and life itself. Understanding this deep history gives us context for today's world and reminds us that change is the planet's only constant. For millennia, humanity built cities atop moving plates, unaware of the forces below. Today, our activities like deep wastewater injection or dam construction can trigger small earthquakes in sensitive areas, a phenomenon called induced seismicity. While we can't make plates move faster or cause more volcanoes, our choices increase our vulnerability. As cities grow in hazardous zones, on coasts, near faults, and on volcano slopes, the risk of disaster rises. A quake that once caused little damage could now devastate a metropolis. Our development patterns, not the planet's behavior, are putting more people in harm's way. Plate tectonics may be unstoppable, but knowledge is our best defense. Scientific research, GPS, seismic sensors, hazard maps helps us understand and prepare for earthquakes, tsunamis, and eruptions. Early warning systems can give precious seconds to act, saving lives and reducing damage. Tsunami alerts, building codes, and evacuation plans turn science into practical protection. Investing in research and resilient infrastructure empowers us to face Earth's surprises. The planet will always be restless, but preparation and awareness can keep us safer. Through knowledge, we transform fear into respect for the forces that shape our world. Our future depends on learning to live wisely, living respectfully on this magnificent moving puzzle.